subscribe.
Hi, my name is Vuba Sadiq with matric number AF210003. Presenting the problem statement, Sarawak experienced approximately 5 series of flood events. A number of factors contribute to Malaysia's flood disaster, one of which is the lack of floodwater storage. The most commonly used measure of human capacity and capacity in the event of any disaster are resilience and vulnerability. The study looked at resilience and vulnerability in managing a flood in Sarawak State. Introduction: the background of study. The designing of a pavement is a process of developing the most suitable economical combination of pavement layers to suit the foundation of oil and the cumulative traffic to be carried throughout the design life of the pavement. Pavement design mainly consists of two parts, which are the design of the material mixture and the design of the pavement structure. During the designs of pavements, aspects like traffic, climate, road geometry, position, soil, and drainage must be taken into account. Road maintenance is also an important component of road system. A flexible pavement distress is the occurrence when the pavement structure no longer holds its original shape and develops material stress which can cause problems like cracking, potholes, and etc. Mostly, one pavement distress and can eventually lead to other pavement distresses to occur. Pavement distresses can be classified into two categories, which are the functional failures and structural failures. Functional failures is the incapability of the pavement to fulfill its function to the standard level of performance that has been specified as satisfactory. However, functional failure not does not cause discomfort to the road users or cause high stress to the vehicles. On the other hand, structural failure is the collapse of pavement structures or the breakdown of components of the pavements and with such magnitude that the pavement becomes incapable of sustaining the loads applied to the pavement surface. The objectives of study: 1. To identify a problematic road that is frequently used by the road users. 2. To determine the level of damage of the road surface by using Pavement Condition Index (PCI) method. 3. To analyze and recommend suitable methods for the rehabilitation of the road surfaces to improve the PCI of the road surfaces. Scope of study. In this study, an attempt was made to determine the level of distress and to recommend suitable maintenance or rehabilitation methods to improve the pavement condition index of the selected road. The study is conducted at Jalan Universiti 1, Parit, Raja, Johor. A distance of 1 kilometer is the selected pavement to carry out the study. The study is carried out on the slow lane of the pavement. Figure 1.1 shows the location of the study area.
Hello, my name is Mohammed Idris Yusuf. I'm from Group 9 and I'm here to talk about our group project lecture review. Road pavements, like all Friday such facilities, are to be compelled and to be maintained. Whereas exploitative road is for transportation, the most road network associated it is managed for associate inertia and anticipated flow of traffic is taken into consideration. Management of road involves among such a massive number of alternative activities. The upkeep of the pavements, usually this can be very often vital to look at the condition of road pavements on their surface life. The event of associate in nursing adequate pavement management system (PMS) might be a really key tool for road agencies. Even in the developed countries, it will be considered sufficient to provide 2 inches asphalt concrete overlay of an old pavement provided funds are available. And now we're going to talk about the methodology, the way we did it. In this section, it's a discussion about the method and the procedure that has been used for the study of this project, which will be used in the achieving the objective of the project. In this project, there were several procedures and strategies that had been done to identify the sources of information and gathering essential information for the analysis and evaluation of the road condition where it is required restoration or just bit maintenance. The methodology review is here. So we start and study the project instruction, choosing the area, choose the road most failure, classify the road failure and doing the PCI index test. These are the steps we follow to do the methodology. First, the instruction was given by the lecturer during the class, and all groups have studied. And second, we choose the area of the objective, and the area we choose was Taman University 2, Parit. And then choosing the most failure of the road are identified based on the criteria. Therefore, the density of the failure is high and need regular maintenance. And at the end, we have to classify the road failure. Road failures are classified based on the type. It will be alligator, butthole, shelving, cracking, etc. And last but not least, this is the equipment we used to do the procedure. This ruler, measuring tape, meter wheel, safety cone, and safety vest, and PCI table to collect the data. Thank you. That's all from me.
Assalamualaikum warahmatullahi wabarakatuh. My name Hamdan Biamsa with metric number CF210321. So I will continue with the part of analysis data. The first step to do is to determine the interval before we conduct the PCI test. In instruction state that we need to conduct 1000 meter in equivalent with 1 km. So we divide our section into 10 number of section, which is one section is about 100 meter. The next step, by using the total section, we found that the minimum to be inspected is 5 by referring on this graph. Then we must to search the interval value with formula total section divided by the minimum section to be inspected. So we get the interval value is 2. So we determine that our section is just to be inspected is only 2 interval. After discussion among our team member, we decide that sample 1, 3, 5, 7 and also 9 will be our section to be inspected.
Hi, my name is Khalid Hamoud Muhammad Al-Sayyaghi. My metric number is AF21302. And I will be discussing the first sample of the calculation part. From when we were in the site, we inspected every section. We divided the section to 10 and we inspected every one to find the distresses available there. And these are the distresses we found in the first section, which is about 100 meters in length and about 7.36 meters in width. Because this section was recently maintained, the amount of distresses we found are little, and they don't occupy a lot of percentage of the density of the section. So the first distress we found is bleeding and it's in low severity, and the other distress we found is shoulder drop off as well. It's also in a low percentage. And we found weathering, which is quite high percentage, but it doesn't the space or the area of the section is very large. We found the total of after we found the length and area of each distress, we found the total. Then we find the density using the formula, which is total over area or length depending on the requirement of the distress. Well, then we multiply by 100 to find the density in percentage. From this density we use the density and deduct value graph for each distress, and we found the deduct values. From then we try to find the maximum allowable number of deducts. For the first section, the highest deduct value was 5. Then we found the m, which is the formula is 1 plus the 9 over 98 multiplied by 100 minus the highest deduct value, which is 5, which gave us the value of m is 9.72. Since 9.72 is less than 10, we try to multiply 0.72 with the number is lower than 9. So the only available number of the deduct value is 5. So when we multiplied 5 with 0.72, we found it to be 3.6. Then from there we found the total deduct values, which is 5, and the from the graph, from the selected deduct value, we found the CDV maximum. For the third sample or third section, all the sections are divided similarly. They are 100 meters in width, and they all have the same width, which is 7.36, which give us the total area to be 736 meters square. But in this third section, we found a lot of distresses. We found bleeding in low severity and medium severity. We found weathering in low severity, and we also found bumps and sags in medium and low severity. We also found alligator cracks, but we repeated the same process. We founded the meters or the areas required according to the requirements. Then we found the total. Then using the same formula, we found the density, and from the density and deduct values graphs for each distress, we found the deduct values. But in this section, the highest deduct value is 25. Then we used the formula of M, and we found it to be 7.89. So the values that are under 7.89, we have 6 and 1. So we multiplied 0.89 with 6 and 1. We found that to be 5.34 and 0.82. Using the correct deduct value, we input them, and we then found from the total of the correct deduct values and the CDV max, and we found the correct deduct value maximum. Then we found out whether 100 minus the percentage of the correct deduct value, and we found whether this road section is good, bad, and not satisfactory, and we found that this road section is in good condition, in a very good condition.
The next slide, I will explain about the sample 5. Through the sample 5, from channels 400 meter until 500 meter, we found that there are 5 types of distress, such as edge cracking with medium severity, long and also cracking low severity, edge cracking with medium severity, weathering low severity, pothole medium severity, and the last is pothole with low severity and medium severity. Then we measure the distress, refer the type of distress. For example, weathering, we using the area to measure the quantity, and then edge cracking and longitude and transverse, we using the distance. While the pothole, we measure by number of pothole. The next step, the way we determine the severity, we refer the standard of PCI. In the standard already mentioned that how we gonna to determine the severity. For example, for the pothole, we must measure the diameter and also the depth of pothole to get the severity. After that, we total up of each distress and then get the density. The last step, we use the graph density, distress versus deduct value to get the value of deduct. The next slide, I will explain about the sample 5. Through the sample 5, from channels 400 meter until 500 meter, we found that there are 5 types of distress, such as edge cracking with medium severity, long and also cracking low severity, edge cracking with medium severity, weathering low severity, pothole medium severity, and the last is pothole with low severity and medium severity. Then we measure the distress, refer the type of distress. For example, weathering, we using the area to measure the quantity, And then edge cracking and longitude and transverse we're using the distance. While the pothole we measure by number of pothole. The next step, the way we determine the severity, we refer the standard of PCI. In the standard already mentioned that how we gonna to determine the severity. For example, for the pothole, we must measure the diameter and also the depth of pothole to get the severity. After that, we total up of each distress and then get the density. The last step, we use the graph density distress versus deduct value to get the value of deduct. The next slide, I will explain about the sample 7, which changes 600 meter until 700 meter. The type of distress that we found are weathering with low severity, bump and sag with low severity, alligator cracking with medium severity, edge cracking with medium severity, and lastly is bleeding with low severity. With the same method as I mentioned before, we found that HDB will be 9. The maximum allowable deduct value will be 9.36. Then the corrected deduct value is 5. The lastly, the PCI value will be 95. So this sample is in category loss A, which is the type activity maintenance that contribute is a routine maintenance. The last part, I will explain about the sample 9, which changes 800 meter until 900 meter. There are 4 types of distress that we found at the sample, which is bleeding with high severity, long entrance cracking with low severity, edge cracking with medium severity, and the last distress is alligator cracking with medium severity. With the same method as I mentioned before, we also found that HDB will be 37. Then the maximum allowable deduct value will be 6.79. Then the corrected value deduct is 39. So we get the PCI value will be 61 with fair condition. So the sample in category loss C, which is the type of activity maintenance that contribute is rehabilitation. So this table is explained about our summary data analysis. In the end of our analysis data, we can conclude that our average of PCI is 81.6, which is in satisfactory condition. Thank you, that's all for me. I will pass to the next presenter.
Okay, Assalamualaikum. My name is Muhammad Arifami bin Khairul Anwar and my matrix number is AF210075. Now I will talk about a discussion. Okay, for the 5 samples, the survey and method for identify distress were conducted. The summary of the PCI values for the 5 samples is included in a table along with the overall PCI and rating for the Jalan Batu Pahat section. Jalan Universiti 1 Parit Raja Johor has a PCI of 81.6, which is rated as very good. According on our review of all the data, sample 3 required more rehabilitation or deferred action than the other samples and had the lowest PCI rating. The observation findings indicate that the sample's root damage included the following types like depression, longitudinal and transverse cracking, patching and utility cut patching, potholes, bleeding, and lane shoulder drop-off. Okay, next for the conclusion, the road was still functioning satisfactorily. According to the data gathered on Jalan Universiti 1, Parit Raja Johor, for the safety and comfort of road users, the authorities in Malaysia must take any road damage seriously. Despite the fact that this highway is a rural area, it still sees a sizable amount of traffic. It is evident from observation made there that a lot of cars use this road every day. Road design that are easier to use and resilient for repeat use should be taken into consideration by the authorities. Since Malaysia has a high average rainfall, which affect the entire road system, road design in Malaysia should also take into account a variety of climatic factors. Researchers should therefore look for novel approaches to create new materials that provide road resistance or waterproofing. Additionally, Malaysian highway agencies need to modernize their current design and maintenance method. More suitable design and practices from other nations must be applied here to achieve maximum user efficiency. That's all from us. Thank you very much.